Hi everyone, in this lecture we are going to design a tie member of a roof truss. So given a roof truss, the member of the truss which undergoes tension, so that means it is undergoing a pull like this, it's called a tension member or a tie member of the roof truss. So we are given that a roof truss consists of the tie member of a roof truss consists of two ISA 100 into 75 into 8 mm, and these are connected to either side of a 10 mm gusset plate. It is subjected to a working pull of 300 kN, and we have to design the welded connection assuming that the connections were made in a workshop. This is what the section will look like. So we have a gusset plate to which two angle sections are fixed on either side. So these are the two ISA 100 by 75 by 8. This is the 10 mm gusset plate. Working load is given to us as 300 kilonewton, and the factored load will be 1.5 times the working load, which is 450 kilonewton. To find out the thickness of the weld, in this case we have to see two criteria. One is at the rounded toe of the angle, at this point here at the rounded toe. As per IS 800 2007, we know that the size should be 3/4 of the thickness of the leg, and the thickness of the leg is 8 mm. This works out to be 6 mm. Next, we also have a square edge at the top. And there the size should be thickness of the leg minus 1.5 mm. This is again a clause by the IS 800 2007, and this is 6.5 mm. So let us adopt a size of 6 mm weld. Each angle carries a factored pull of 450 divided by 2, that is 225 kilonewton. Let us say that L suffix W is the length of the weld required. Assuming that the weld is normal, that means the angle is 90 degrees. That means K value will be 0.7. The design strength of the weld is given by the area of the weld. Area is given by LW into T. This is the area of the weld. into FU by root 3 into 1 upon the partial safety factor, and the partial safety factor for welds done at the workshop is 1.25. Let us substitute the values that we know. FU in case of rolled sections is 410 Newton per mm square. Now we have to find out LW. In order to find out the length of LW, we have to equate this equation to the factored load. So let me label this equation as 1 and this equation is 2. Equating equations 1 and 2. We get LW into 4.2 into 410 upon root 3 into 1 upon 1.25, 225 kilonewton. Since everything is in Newton, I am multiplying this by 10 to the power 3. From this I get the length of the weld required is 283 mm. Now, how do I provide this length? We have an angle section. So they are not symmetrical, they are not equal angle sections, as we see that the leg lengths are different and they are connected by the longer leg. So for that we need to find out how much length is required at the top part of the angle and how much at the bottom. So we have a section something like this. Okay, this is 100 mm. This is a longer leg which is connected. This is a gusset plate of 10 mm thick. We need to keep in mind that the CG of the weld has to match with the CG of the section that we are providing. So in the other problems that we have solved, we have joined two plate sections and the plate sections were symmetrical. So the length that we provided on either side was equal. Okay, so in this case we have an angle section which is unequal. That is why the length at the top of the angle section might not be same as that at the bottom. So now we have to find out. We know that from the steel tables the value of Cxx is given to us, and that is the center of gravity of the section, and it is 31 mm in this case. Okay, so Cxx is 31 mm from top. Now let L1 be the length of the top weld. Okay, so this is L1 and this is L2. In order to make the center of gravity of the weld to coincide with that of the angle, okay, we have to equate L1 into 31 equals to L2 into 100 minus 31. Okay, so this distance here is 100 minus 31. So we get L1 equals to 69 upon 31 L2. We also know that the entire length L1 plus L2 should be equal to 283. That is this value that we have obtained earlier. So now substituting L1 in terms of L2. We get L2 as 87 mm and L1 is 195 mm. So therefore, we provide a 6 mm weld of L1 is 195 mm and L2 is 87 mm. This has to be clearly depicted in the picture. So this is what it will look like. So we have a gusset plate 10 mm on either side of which we have ISA 100 by 75 by 8. It is connected by the longer leg to the gusset plate, and L1 is 195 mm and L2 at the weld length at the bottom of the angle is 87 mm. This solves our problem of design of a tie of a truss member. Thank you.